Okay, so this is the next step. I've never done this before, so it should be kind of interesting. I know people are asking me, well, what about when these objects, they disintegrate? You mean to tell me that something the size of the Earth eventually becomes something like this? What I'm saying is, yeah, the whole thing disintegrates, leaving the very center iron core left over, which then starts getting ripped up and torn up and shredded apart. Now, I polished that side just to see what was inside. This is an iron nickel meteorite, and I'll show you where this would fit as a meteoroid in outer space on this graph. So everybody's familiar with this portion. You have the stars moving down here. Duh, everybody knows this. But it gets more interesting when you go down, because the material, it does disintegrate. Right below this little line right here would be small planets and moons. This is where small planets and moons fit in right here. And then you have medium and large asteroids. These are the size of like Ceres and, what are called comets, but actually just highly elliptical asteroids. And objects the size of cities. And then you have small asteroids. These are like, battleship or skyscraper sized objects. And you have meteoroids. If this was in outer space, it'd be classified as a meteoroid. Luckily, it landed on the surface and somebody found it and picked it up, and I bought it. Now it's in my possession temporarily until I give it to somebody that will then keep it for me, or who knows what's going to happen to this thing. Anyways, that's a meteoroid. If that was in outer space, that would be a meteoroid, but right now it's a meteorite because it's already landed. And then you have gas and dust. If you break this up in outer space into little bits and pieces, it will become gas and dust. Free iron particles floating in outer space, ionized iron particles, and whatever in here will be just completely obliterated over time or recycled into one of these objects up here. And that being said, the reason why it works like this is because this is the direction the mass goes. The mass goes down. This line right here, this little black abyss, I guess you could say, is where the mass just completely disintegrates. There's nothing down here. This is nothingness. The reason why I went ahead and did black is because it symbolizes the black of outer space, where there's nothing around. And that's kind of scary, but there's a lot of this black stuff too. There's nothing there. And for those that are confused, zero mass, I mean 0 kilograms, 0 tons, 0 pounds, 0 grams. Nothing is left of the star. It is gone. Meaning the star no longer exists. It's already been recycled into these objects up here. I guess this video is kind of long enough, but as you can see where I'm going, the phase curves, they curve all the way down. And I'm not saying this, don't interpret it like this. You can't take something the size of Venus and move down the phase curve, because everybody knows this is time. Time goes in the arrow of this direction. So people say, oh, well, the phase curve means that Venus, it goes down this direction. No, you would be going backwards in time if you did that. Venus just goes all the way down here. And I did not include this portion, but it will be the same as down here. It just keeps on going and going and going. Of course, this curve would probably move down like this and expand downwards. I didn't put that for this example. I just wanted to make it clear and where people can see it like this for now. See, what else did I want to talk about? Oh yeah. This is evident that even when you have objects like that, and they could probably evolve so fast that they disintegrate and disintegrate and disintegrate, and eventually not become anything at all. because maybe sometimes an object like this, like a red dwarf or orange dwarf, will just fly down here and then become nothing of significance really, really quickly. And that's pretty scary too. Don't think that that's very probable. I think the more probable lines are in this general vicinity, and this general vicinity right up here. But to go like down here and to make them evolve extremely fast, where they just disintegrate almost as soon as they're born, relatively speaking, I don't think that's possible. But they can go really fast. So I guess you could say, statistically, if you were to put this on like some type of bell curve, the stars that evolve. Okay, so you have a little bell curve. The stars that evolve really, really slowly are over here, and the stars that evolve really, really quickly are over here. So this would be an extremely large end result object, which would be sitting probably up here, and then this being something that would be sitting way the hell down here somewhere. But the majority of the objects, they sit inside 3 standard deviations of the mean. So this is the mean, 1, 2, 3 standard deviations, 1, 2, 3. And I think for the most part, the majority of the objects, the mean, would probably be objects that host life. So probably the objects that evolve in this sweet spot right here are the objects that host life. And that being said, the meat of the bell curve from 2 standard deviations down here to 2 standard deviations down here is basically all this area. And the ones that are, or I should say, probably down to here at least, yeah, down to here, all this area right here. But then once you go to 3 standard deviations and below, that would be like way the hell down here. Anyways, I think that sums it up. I mean, I'm probably going to make more of these videos, but keep that in mind. As the stars disintegrate, they lose their mass, they lose their mass, they lose their mass, and then they just become gas and dust. All right, you guys, take it easy.